Hello everyone. Today I am going to show you the program of Jkff flip-flop. So here in the programs tab I have already written the Jkff flip-flop program. Now I'll explain the Jkff flip-flop. So this is the program of Jkff flip-flop. See here the positive edge of the clock is considered. The inputs are J, K and the clock. The outputs are Q and QB. So here the program works like this. Whenever 0 1 is given, the output will be 0 1, that is q qb are 0 1 respectively. Whenever jk is equal to 1 0, the outputs q and qb are 1 0 respectively. When it is 1 1, that is when j is equal to 1 and k is equal to 1, q and qb toggles, and when j and k is equal to 0 0, the previous state will be followed. This is how the jk flip flop works. So here inputs are considered as J, K clock, and the outputs are Q and QB. So here the outputs are considered as registered in the Verilog code. Initially Q is equated to 0 and QB is equated to 1. So case program is considered. When there are different possibilities, we do consider the case. So j k cases are considered. So when j is equal to 0, j is equal to 1. When j is equal to 1, when k is equal to 1. When j is equal to 1 and k is equal to 0. So all the possibilities are considered here. So that means when 0 0, q is followed with the same previous state q. When it is 0 1, it is q is followed with 0 and qb will be obviously 1, because we have considered the inversion of q. And when it is 1 0, q is 1 and qb will be 0. When it is 1 1, q is equated to qb and qb is equated to negation of q. So that means it toggles. This is the Verilog code. Now let us move on to test bench of Verilog code. Here the inputs are considered as registers and the outputs are considered as wires. So the instantaneous unit under test are considered for J, K, clock, Q and QB for all inputs and outputs. Initially J, K, clock are all assigned with zeros. Now with the delay of 10 seconds, here clock begins. So here when J and K different cases with 0 0 0 1 1 0 1 1 are considered, with a delay of 30 nanoseconds we can observe the outputs. This is about the test bench. Now let us run the program. To run the program, go to digital, there open terminal, csh. So here we are invoking the cadence digital tool. Now type source cshrc underscore test. Now it shows welcome to cadence tool suite, and to open or to write, to execute the Verilog code, you have to type nc launch. So when we type nc launch, just enter. So nc launch program will be opened. Here we get the different programs. In the programs Verilog, as Jkff flip-flop is considered, just click on the Jkff flip-flop. So before going to that, delete all the programs which are already executed in the work clip. So I am deleting the previous programs which are executed in the work clip. Now consider Jkff flip-flop, run the code. So launch the program. Now it will come under work clip, and similarly jk underscore tb, again launch. Now we get these two library under work library. Now Jkff flip-flop has to be elaborated. Just click on this launch elaborator with the current selection. So I have selected Jkff flip-flop. Just launch it, and also jk underscore tb, just launch the program. And now as we need the test bench output, click on snapshot and click on the test bench, and now launch the simulator with the current selection. So just launch the simulator to check the output. Here console and the waveform window will be opened. So just minimize the console window, and here we have jk_tb program. From this, send all the waveforms to window. Now all the waveforms to window is sent to the waveform window, and here we have to give 400 to 500 nanoseconds and just run the program. So here we get the program. So whenever j and k are 0 and 1, the q and qb is 0 and 1. Whenever it is 1 0, the q and qb is 1 0. Whenever both are 1 1, see here you can observe it just toggles. And whenever it is 0 0, that means it follows the previous state that could be observed in this state. So this is how we have to check JK flip-flop. Thank you for listening.